Hello everybody, I'm Adam. In this problem, we're going to be finding the distance from the point given by coordinates 1, 5, and -2 to the line given by parametric equations x equal to 4t minus 2, y equal to 3, and z equal to -t plus 1. So first let's start with what we know, and that's how to find the distance between a point and a line. So what we know is that the distance between a point and a line can be found by taking the magnitude of the cross product of the vector from P to Q crossed with the vector u divided by the magnitude of u, where what we have is the point Q. That's the point, say, in space that we're trying to find the distance from that to the line. We have the point P. That's a point that lies on the line. And then we have this vector u, and u is a direction vector. Of the line, or a vector that's parallel to the line. So if we can find these three things, we have enough to plug everything into our formula and find the distance. So let's start with what we know, or what's easy to find. So let's take a look at u, our direction vector. So our vector u, which we generally can take with components a, b, and c, where the a, b, and c are the numbers being multiplied by the parameter t in our parametric equations. So a is the number multiplied by t in our parametric equation x equal to 4t minus 2. So we have component 4. b is going to be equal to, say, 0, since there is no t term. And c will be equal to -1 from our equation z equal to -t plus 1. So there's our direction vector. So we have u, and q, which is the point in space that we're trying to find the distance from, that's our given point, with coordinates 1, 5, and say -2. And then lastly, we need to find a point on the line, say P. Now how can we do this? Well, if we take a look at our parametric equations, it's exactly how these things get used. If we look at them, for different values of the parameter that we plug in, we get different values of x, y, and z, which give us the coordinates of points that lie on the line. So we can simply take a value of t and pick one that's easy to compute with. Let's say t equal to 0. So that's going to imply if t is equal to 0, x will be equal to 4 times 0 minus 2, or x equals -2. When t is equal to 0, y is still just the constant 3. So y equals 3, and z, when t is equal to 0, z will just be +1. So there's our point P, which will have coordinates -2, 3, and 1. Okay, so building our way up, the next thing we need is the vector from P to Q. So the vector from P to Q, treating Q like our terminal point, P is our initial point, doing component-wise subtraction. So 1 minus -2 gives us +3. 5 minus 3 gives us +2. And -2 minus 1 gives us -3. Okay, so now we have the vector from P to Q, and the next thing we're going to do is find the cross product from P to Q and u. So let's take our cross product, and the vector P to Q cross u, and we'll do this using our determinant form. So we'll take the determinant of the 3 by 3 matrix, where our top row is the unit vectors I, j, and k, and the second row is the components from our vector from P to Q, which we have as 3, 2, and -3, and the last row is the components from the vector u, which is 4, 0, and -1. Okay, so let's give ourselves some space. So we want to find the numbers multiplied with I, j, and k. Starting with I, We cover up the I column, and we're going to take the determinant of the 2 by 2 matrix that's left with our components, or entries 2, -3, and 0, and -1 by multiplying across our diagonals and subtracting. So 2 times -1 minus 0 times -3, or 0, just leaves us with -2. For the number in front of j, we cover up our j column, and we have 3 times -1 minus 4 times -3, which gives us, say, a +9. And for the number in front of k, covering up our k column, we have 3 times 0 minus 4 times 2, or -8. So in component form, our cross product can be written as -2, -9, and -8. Okay, so now we have everything to start plugging things in to our equation to find the distance. So our distance, d, we'll just bring it down here, once again is the magnitude of the cross product between our vector from P to Q cross U divided by, say, the magnitude of U. Okay, so the magnitude of our cross product is the sum, or the square root of the sum of squares of the components. So the square root of -2 squared plus -9 squared plus -8 squared, and divided by the magnitude of U, or again the square root of the sum of squares, say 4 squared plus 0 squared plus -1 squared. Okay, what do we have? So we'll check this in our calculator. So in the numerator, we have -2 squared plus -9 squared plus -8 squared. That will give us, say, the square root of 149. And in the denominator, we have 4 squared plus 1, or 17. So that's pretty good for our distance, but we'll go ahead and rationalize the denominator. So we'll multiply top and bottom by, say, the square root of 17. So that's going to give us, in our denominator, just 17. And we'll simplify the numerator by multiplying under the square root 149 and 17. So 149 times 17 gives us the square root of 2,533. So our distance from the point to the line given by our parametric equations is the square root of 2,533 divided by 17. Thank you very much.